This video will be part 2 on our lesson on stretches. So we're going to take what we learned in part 1, which was basically the introduction of the A parameter and the B parameter, and then we're going to apply that to questions in part 2. You need your note package for this. Some of the questions that I'm going to do actually correspond to questions right from your workbook. And the reason why I like telling you that, so for example, this question that we'll do in your note package, it's also in lesson, you'll find it a blank copy of this question, lesson 5, page 115. It's class example 3. So I always like I said, to tell students that, because once they're practicing or studying, if you open up to that page, class example 3, you'll be able to redo this question by yourself, see if you understand it. So again, part 1, we did our transformation. So our original function is y is equal to f of x. And I said, okay, let's introduce two new parameters, which are the a value and the b value. And the a parameter is outside of your function, and that would be a vertical stretch. And the stretch factor is whatever that a value is, right? So if the a value is 3, the stretch factor is 3 as well. The b value is your horizontal stretch. And the stretch factor, it's always the reciprocal of the b value. So if your b value was 5x, your b value would be 5, your stretch factor would be 1 over 5. Okay, so let's look at this example. What happens when the graph of the function y is equal to f of x? What happens to this when you make these changes? So it says replace x with 4x. So this is replacement notation. So they want you to take out that x. So the original function was y is equal to f of x. And they want you to replace the x with 4x. F of 4x. You should be able to look at that and you should be able to say, okay, that is a b value. My b value is 4. What does that tell you? It is a horizontal stretch, and the stretch factor, because it's a b value, it's always the reciprocal. So the stretch factor is 1/4. For b, I want you to star this one, and we're going to star c as well, because it's a little bit trickier at first. So now we're going to replace y with 1/3 y. So replace y with 1/3 y. So you say, okay, my original function was y is equal to f of x. Let's take this y out and replace it with what they want us to, which is 1/3 y is equal to f of x. Now we need to isolate y, so you need to get rid of this 1/3. So the opposite of 1/3, like in order to get rid of that 1/3, is I could times this by 3 and times this by 3, right? Because 3 times a third would cancel. Then I would get y is equal to 3 times f of x. Now, what I just gave you, with replacement notation, we're figuring out if we're replacing y, we're getting the a value. So when I replace y with 1/3 y, my a value is not 1/3. My a value, once I bring that 1/3 over to this side, right, by canceling out the 1/3 by doing the opposite, multiplying by 3, my a value is actually 3. That tells me it's a vertical stretch, and the stretch factor is equal to 3. Okay? If you understand that, you'll hopefully get C, because we're going to be doing two stretches here. So we're going to do a vertical stretch and a horizontal stretch. But what it wants us to do, it wants us to do two replacements. So it says replace y with 6y and replace x with 6x. Or sorry, replace y with 6y and x with 1/3 x. Okay, so our original function is y is equal to f of x. Let's do those replacements and then see if we could figure out what the transformations were. So y is going to come out and 6y goes in. And within the function, x comes out and 1/3 x goes in. Oops, sorry, that x should be within the function f. Take the x out and put 1/3 x in. Okay, So students right away can look at this and they could say, okay, that's my B value. My B value is equal to 1/3. My B value is my horizontal stretch, and my stretch factor is the reciprocal of my B value, so it's going to be 3. Okay, now the A value, it's not here yet because we got to get rid of this 6. So right now, y is being multiplied by 6. So the opposite of multiplying this by 6 is dividing this side by 6 and dividing this side by 6. Now there's an invisible 1 here, right? So what my new function would be after those two transformations, it's y is equal to 1/6 times f 1/3 times x. So we've already done the b value, which is 1/3, and now I have my a value. So the a value is always in front of your function, right? So my a value is equal to 1/6. That is a vertical stretch, and the stretch factor is equal to whatever that a value is. So the a value is 1/6. Now, if I was to do my mapping, let's do the mapping for all three of these. So for this one, remember our mapping, it's x comma y goes to um, x over b a times y. So this one would be x comma y. This was a b value, which was 4. So this would be x over 4, and there's no a value. So we'd get y, right? So that would be this mapping notation. Okay, this guy here, we had an a value of 3. So the mapping, it's x comma y to x over b. There's no b value, so I'm just going to omit it. A times y. That our new coordinate would be x, the a value, what was our a value? 3y. That would be the mapping, xy to x3y. This one here, okay, it's xy to x over b a times y. So it would be xy mapped. Okay, so x over b, what was my b value? So my b value was 1/3. So remember again, so it's, I could say x over 1/3. And then what's my a value? A value is 1/6. So 1/6 times y. Now, this is messy. You would never leave this. I would take off a mark if you left it like this. X divided by 1/3 is the same thing as 3x 1/6y. So remember, you're always taking your x and your y coordinate and you're multiplying it by this stretch factor. So here the stretch factor was 1/6. I multiply it by the stretch factor. Here, my for my b value, the stretch factor was 3. So I'm multiplying it by 3. Okay. Okay, let's do this example here. So again, I always like writing y is equal to a f open bracket b of x. And then I always like saying vertical stretch, horizontal stretch. So I find that that just helps students. So they've given us the graph, this graph here, and they said this is the graph of y is equal to f of x. So let's write that down. And then they want us to sketch this graph after it undergoes the following transformations. So you need to be able to look at this and you need to be able to say, okay, so what are the transformations? What is this letter? So that's your A, and A is -1/2. So if it's in front of your function, that's your A value. And this is your B value. So B value is equal to 4. Okay, let's write everything that we know. So if our A value is -1/2, that is a vertical stretch. Stretch factor is equal to. Now, remember I mentioned this in the last video. If your A value is negative, your stretch factor, it's the absolute value of that number. So the absolute value means we just don't say the negative. So my stretch factor is 1/2. Now we do have to account for this negative. What does that negative mean? If we have a negative in front of our function, that is a reflection. So if a is less than 0, What that means, it's a vertical reflection about the x-axis. Because remember, y is being transformed to negative y, right? So that's going to be a vertical reflection about the x-axis. So if your a is negative, vertical stretch factor is 1/2, but that negative is a vertical reflection about the x-axis. Okay? Now, my b value is 4. So let's write that down. B value is equal to 4. Okay, what does that tell us? B value is a horizontal stretch by a stretch factor of the reciprocal, which is 1/4. So if I was doing my mapping, and we're going to pick points on our graph, it's xy gets mapped to x over b, a times y. Xy gets mapped to x over b. So our b value is 4. So I could say like x divided by 4, or I could say a quarter. Remember our stretch factor times x. It's going to be the same thing, right? X over 4 is the same thing as a quarter times x. And my a value, what was my a value? A is negative 1/2. So I'm multiplying my y's by negative 1/2. Okay, that's going to be my mapping. So what you want to do is you want to get some nice points on your graph. So maybe 3 points is all we need. Let's take this point. So let's take negative 4, 4. Let's take our vertex, and let's take this point. And let's perform those transformations on these 3 points and see where it gets mapped to. Okay, so my 3 points that I said was negative 4, oops, okay. So my 3 points, negative 4, 4, and 0, 0, and 4, 4. Okay, so negative 4 divided by 4 and negative 1/2 times 4. That is going to be negative 1 and negative 2. So this point goes to x is negative 1 and y is negative 2, right? So this point here is now this point here. Okay, 0, 0. So 0 divided by 4 is not going to change that coordinate. Negative 1/2 times 0 is not going to change that coordinate, or sorry, that point. So 0, 0. This is going to be an invariant point. So that's already there. And now let's take this guy and see where that point is going to transform to. So 4, 4. So take that x and divide it by 4. Take the y value, which is 4, and multiply it by negative 1/2. And we are going to get 1, negative 2. Which is right here. So my new graph, using your ruler if it's in blue, is going to be here. So this transformation was a reflection about the x-axis. So it underwent a vertical reflection, and the graph underwent a vertical stretch by a factor of 1/2 and a horizontal stretch by a factor of 1/4. And this is what our new graph would look like. Okay. Okay, next question. It's going to correspond. So again, if you want to redo this question later on, it's on page 121, class example number 1. Okay, so let's look at this one. So write the equation of the image of. So y is equal to x squared is our function. And it says it wants it to undergo a horizontal stretch by a factor of 3/4. So again, let's just write above this, y is equal to a f b of x. And then I always like saying that this is a vertical stretch and this is a horizontal stretch. Okay, so horizontal stretch, I've underlined. So that is going to be a b value, right? So this is going to have to do with our b value, horizontal stretch. They say that the stretch factor is 3/4. So the b value, remember, the b value, it is always the reciprocal of, like your stretch factor is always a reciprocal of the b value. So if our stretch factor is 3/4, our b value is 4/3. Okay, that would be our b value. And when we do our replacement notation, you're always going to replace x with whatever that b value is. So the replacement notation is x is going to be replaced with 4/3x. So this was your original equation. So if I didn't give you that, let's say it was just y is equal to f of x, then that would be replaced with y is equal to f of 4/3x, right? That would be the replacement notation. So this is my b value of 4/3. The stretch factor is 3/4. But they actually want us to, this is the equation. So they're giving us what the function is. So what we have to do in this case is y is equal to x squared. We need to take out this x and we need to put in 4/3 x. So that's going to be y is equal to, take out that x and put in 4/3x. Okay, so that goes within the function. So my squared is on the outside. And then now what I could do is that squared applies to the x, to the 4, and to the 3. So this becomes y is equal to 16/9 x squared. Okay, so within the function, I replaced x with 4/3 x, and then I squared it. So my new image function, or my transformed function, is 16/9 x squared. I have B starred. There's a lot going on in B. So what's going to happen in B? And this would probably be a standard of excellence question. So they give us this function here. So they give us y is equal to the square root of x minus 3. And then they say, okay, please have it undergo a horizontal stretch by a stretch factor of 4. So stretch factor is equal to 4. If it's horizontal, so if we go back up here, horizontal is our b value. So if our stretch factor is 4, what's our b value? B is 1/4. Okay, this is replacing x, right? So our replacement is going to be x with 1/4 x. I'm going to take that x out and I'm going to put in 1/4 x. And it says, please undergo a vertical stretch by a factor of 2. Okay, so stretch factor is equal to 2. If it's a vertical stretch, so let's scroll up to our little cheat sheet. If it's a vertical stretch, that's our A value. And remember, A value and stretch factor, they're the same. So the A value is going to be equal to 2. Now, the replacement though, and you have to think of this previous example here. This example here. If your A value is 3, what the replacement was y is replaced with 1/3 y, right? So if we want our A value to be 3, our replacement is 1/3 y. So going back to this question, if they want our A value to be 2, in order to get an A value of 2, the replacement is going to be 1/2 y. And I'll show you, it will make sense when we actually do this question and you'll see it. Okay, so let's take this original function and let's do that replacement. So that's our original function. Y is equal to the square root of x minus 3. Let's replace our y with our 1/2 y, and let's replace our x with 1/4 x and then minus 3. We just did our replacement, okay? Now we've got to do a couple of things. I need to get my a value over here. I want to see, we want y isolated, right? So y is being multiplied by 1/2. I want to get rid of that 1/2, so I'm going to multiply this by 2 because I just want to get rid of that 1/2. So I'm going to multiply both sides by 2. Okay, because 2 times 1/2 gets rid of my 1/2, and now I've got y is equal to. So y is equal to 2 open bracket 1/4 x minus 3. Now I hope you could see, yes, my a value is in fact 2, and my b value is in fact 1/4, right? So my a value is 2, my b value is 1/4. Now, this is correct, right? It shows us our a value and it shows us our b value, but then this question's not done because I could actually further simplify this. So what I would have to do is I'd need to multiply the 2 in. So this is going to be y is equal to 2/4 x minus 6. And then the last thing that what makes this question tricky is the square root of 1/4x. Basically what that is, so the square root of 1/4x from radicals, this is really the square root of 1 over the square root of 4. And the square root of 1 is 1. The square root of 4 is 2. So if you see, like, what's the square root of 1/4, that answer is 1/2. Okay? So what this becomes is y is equal to 2 times 1/2, because the square root of 1/4 is 1/2, times root x minus 6. That becomes 2 times 1/2 is just 1. So the answer is actually root x minus 6. So again, this would be like a standard of excellence question. Okay, C as well. You're going to see, like, if you understand B and C after you watch the video a couple times on these questions, you get this. Here's the original question, the original function. They wanted to undergo a vertical stretch. So they're saying, take this, and I want it to undergo a vertical stretch by a factor of 1/3. So vertical stretch is your a value, right? So stretch factor is equal to 1/3. Therefore, a value is equal to 1/3. What was the replacement though? So the replacement, actually before I do the replacement, and a reflection in the x-axis. So remember a reflection in the x-axis, what becomes negative? So a reflection in the x-axis is y goes to negative y. So what that actually means is that my a value is negative 1/3. Okay, so a reflection in the x-axis, y goes to negative y, so my a value is negative 1/3. Okay, so two things are happening. Y is going to negative y, and y was going to 3y. So remember when we do a replacement notation for our a value, y goes to 3y. This, putting it all together, is y is going to be replaced with negative 3y, right? Because there's the reflection here. So I'm just going to combine these two. So y is being replaced with negative 3y. Okay? So my original function was this guy here. Y is equal to 3x plus 7. And I need to replace this y with negative 3y. So students will get to this point and they'll be like, okay, like this is correct. And then sometimes they'll mess up on the manipulating. So in order to get rid of this -3, I'm going to divide both sides by -3. And what you have to do on this left hand, or sorry, on the right hand side is, well, we could do a couple of things. There's two different ways we could write this. This -3, it applies to both that 3x is being divided by -3, as is that 7, right? So this is one way we could do it. And we could say, okay, the answer is -x minus 7 over 3. That's one answer. Or if I do this, if I write it over here, 3x plus 7 divided by -3. What you could do is you could put this in a bracket and a 1 in front of here. And that's the same thing as saying 1 over -3, 3x plus 7. And then you distribute in this. So whichever method you like. -1/3. Oh, and this shows you your a value. So I actually sort of like this method because this shows you your a value is -1/3. And then we're going to distribute it in to simplify. So -1/3 times 3 is -x. And -1/3 times 7 is -7 over x. So it doesn't matter which one you go to, you get the same answer. Okay, another question. This one's not in your workbook, I don't believe. The graph of h of x, so here's h of x, is a transformation image of the graph of y is equal to the square root of x. So this is my original graph, and this is my transformed graph. Corresponding points are labeled. So A goes to A prime, B goes to B prime. Write an equation of the image graph in terms of x. Okay, so just using points now, we're going to be able to figure out what our A and our B value is. So what's happening is we're getting this original graph, and it's being transformed to this graph here. And they want to know like what our a value is. So what is going to be in front of this function, what's going to be inside the function, like what's our a value and what's our b value. And the only thing they give us is points. Okay, so how we do this is you take your first point that they give you, which is a, and they say that this point is at 1, 1. After the transformation, that point becomes a prime. The image point is a prime, and a prime is at -1, 3. What we are going to look at is what happens to our x, what happens to our x's, and what happens to our y's. Okay, now before we do that, let's do our b and our b prime. So our b coordinate is right here, and that is at 4, 2, and b prime up here is at -4, 6, 6. So again, so look at, so this went from 1 to -1. This x coordinate went from 4 to -4. So what do you think is happening with our x coordinates? So going from 1 to -1, 4 to -4, what would that stretch factor be? And remember, this is going to be our b value. So our stretch factor is 1, but there's a reflection happening, right? So in order, if you go from a positive to a negative, there's going to be a reflection happening. So it's going from here over here, there's a reflection in the y-axis. So what that means is our b value is -1, right? All they did to this coordinate is they times it by -1. by the stretch factor of -1. Now let's look at our y coordinate. So this 1 became 3. This 2 became 6. What did they multiply the y coordinate by in order to go from a 1 to a 3 or a 2 to a 6? They multiplied the y coordinate by 3. So the stretch factor is equal to 3. The y coordinate has to do with the a value. So our a value is equal to 3. Okay? So our y is equal to f of x gets transformed to y is equal to a f b of x. Our a value is 3 and our b value is -1. So what they want us to do, we got to take our original equation. So they said our original function is y is equal to the square root of x. And if they want our a value to be 3, it's going to be 3 root -x. Oops, and I should have, actually, let me just clean that up. So y is equal to 3 root -x. If I was showing this with replacement notation, what my replacement notation would be is x is being replaced with -x and y is being replaced with 1/3 y. So again, just showing you, because I might say on a test, do this by replacement notation, and actually it's the best if you do it by replacement notation. So y is equal to square root of x was our original function. Let's replace y with 1/3 y. Let's replace x with -x. And then we need to isolate y by itself. So how we get rid of a third is we multiply both sides by 3 and by 3. And we get y is equal to 3 -x. And that is going to be the equation of the transformation image. And the transformation image was that red line, or this red radical up here. Okay? Okay, 2 more questions. So the point 36,6 lies on the graph of this radical function y is equal to the square root of x. What are the coordinates of the image A prime on this graph here? Okay, so a couple of things. Let's write y is equal to square root of x was our original function. It underwent this transformation. So y is equal to -1/2 square root of 3x. Okay, so once you have your transformation, get your a value and your b value. So my a value is equal to -1/2. Now, that -1/2, remember that's a vertical stretch. Stretch factor is equal to 1/2. And because a is less than 0, it's negative, it's a vertical reflection, right? And it's a vertical reflection about the x-axis. So y goes to -y. This is our b value. B value is equal to 3. That's a horizontal stretch. Stretch factor is the reciprocal, which is 1/3. Okay? So we take they want us to basically map. So they give us a point. Before I do that though, I'll do the mapping. X comma y goes to x over b a times y. Okay. X comma y goes to x over b. So x over 3. Remember, I could say x over 3, or I could say x times a third. That's the same thing. X over 3 is the same thing as x times a third. And then my y point is a times y. So negative 1/2 times y. So the coordinate for a, they said was 36, 6. And the coordinate for a prime is 36 over 3, negative 1/2 times 6. So a prime, what would that be? 36 divided by 3 is 12, and 6 times negative 1/2 is negative 3. That would be our new a prime. Okay, the last question. The last question is from your workbook. So again, when you're practicing, uh, redo this question in your workbook when it's time to study, let's say. And this is a really, we see this question often on diploma. So this is a really good question that I always tell students to star. And that means I'm going to put it on either quiz, exam, something, you'll see it. So a polynomial function has this equation here. X minus 4, x plus 3, x plus 6. We're going to do an entire unit on polynomials. Though you did do quadratics in Math 20-1, this polynomial function is essentially factored. And when it's factored, you could look at these factors and get what the zeros are. So this 0 here from quadratics, x minus 4 is equal to 0. That x-intercept, or that 0, is at 4. This 0 or x-intercept is negative 3. And this 0 or x-intercept would be negative 6. Okay, so these are the zeros of the function, which are the x-intercepts of the function. So we have 3 x-intercepts at 4, negative 3, and 6. If you wanted to, you could actually punch this into your calculator. So I'll show you what I've done. I've punched in this polynomial into my calculator. I did change my window. So I changed my window, my y min negative 100, y max 100, my scale factor 10. When I graph this, here's my graph, and here's the x-intercepts. This guy would be negative 6, that guy would be negative 3, and that guy would be 4. Okay? So these are give you the zeros of the function. So what it says, okay, so a polynomial function has this equation. Determine the zeros and the y-intercept if the following transformations are applied. So the first thing I want to do is let's just write the zeros of the original function. So the zeros, remember another word for zeros are x-intercepts. So it's what we just talked about. So the zeros of this function are x is equal to, so what were my x-intercepts? Negative 6, negative 3, and 4. Or I'll just do it in order, I guess. 4, negative 3, and negative 6. Those are my x-intercepts of my original function. If I said, what's the y-intercept of this function? I'm going to show you 2 ways to do this. If you were doing it on your calculator, the y-intercept, second function, trace a value. The y-intercept is when x is 0. So when x is 0, y is negative 72. Now here's the thing. I might ask you to show me this algebraically. So how you would show that, the y-intercept, it's when x is equal to 0. So within this function here, we're going to put a 0 in for our x. So p of 0 is equal to, whenever you see an x, put in a 0. 0 minus 4, 0 plus 3, 0 plus 6. P of 0 is negative 4 times 3 times 6. Negative 4 times 3 is negative 12, and negative 12 times 6 is negative 72. So the y-intercept is equal to negative 72, or we would say when x is 0, y is negative 72. Okay, so it's really important that when we're doing these type of questions, we get the original zeros and the original y-intercept. Now we could actually do the question and say, okay, what is going to happen to these zeros? So to 4, -3, and -6. And what's going to happen to this y-intercept when it undergoes this transformation? So let's see what this is. That's our a value, and a is -3. So let's write that down. A is equal to -3. Okay, so that's a vertical stretch and a vertical reflection. So xy goes to x a times y. Xy goes to x -3 times y. Now, our coordinates, these are x-intercepts. So let's write these as ordered pairs. So if my x-intercept is 4, that ordered pair would be 4, 0, right? My next intercept is -3, 0. My last x-intercept, 6, 0. And my y-intercept, so the last point I want to check is this guy right here, which is 0, -72. Okay, so let's see what happens to this polynomial function. So to this graph here, what would happen to the x-intercepts and the y-intercepts if it undergoes a vertical stretch and a vertical reflection? So the x-coordinates stay the same, right? The x-coordinates stay the same, and the y-coordinates get multiplied by 3. So let's see what happens. This becomes 4, 0. -3, 0, 6, 0. This guy I have to multiply by -3 because these guys multiplied by -3 doesn't change, right? But -72 times -72 times -3 is 216. So what I'm hoping you notice is if we have a vertical stretch, the x-intercepts do not change. So they're invariant points. Invariant points. So for vertical stretch, x-intercepts are invariant points. What changed was my y value. So what actually changed is my y value. So a vertical stretch affects y values, which is going to be the range of my graph. Okay? So again, if I take that function and I put a -3 in front of the function, so I could show you, how could I do that? So y is equal to, so if I put a -3 in front of here, and then I'm going to do x minus 4, x plus 3, and x plus 6. So this is going to be a reflected graph, and there's going to be a stretch. My x-intercepts shouldn't change, my y-intercept should. So look at that. My x-intercept are invariant points because it's underwent a vertical stretch. My y-intercept, let's actually just look at the new red graph and figure out, so let's graph just the red guy. Second function, calculate a value when x is 0. There's my new y-intercept, 216. Okay? Okay, let's do the exact same thing. So the original function, the x-intercepts were, what were they? 4 and -3, 0, and -6, 0. The y-intercept of my original function was 0, -72. What we're doing in this example is this is our b value, which is -1/2. So there's going to be a reflection, horizontal reflection. Our stretch factor, there's also horizontal stretch. Our stretch factor is the reciprocal of the b value. It is just 2. Our mapping is x comma y to x over b y. Um, and again, instead of saying x divided by -1/2, right? So x divided by -1/2 is the same thing as -2x. So it's x over b, but our b value is -1/2. So that's the same thing as -2x times y. So to each of these x coordinates, we're going to multiply it by -2 to all my x's. My y stay the same. So multiply each of those x coordinates by -2. 12, 0, and 0. So this one doesn't change. So when we're dealing with a horizontal stretch, the invariant point is going to be the y-intercept, and our the b value or the horizontal stretch affects x-intercepts. Okay, and that concludes your lesson now on stretches.